Okay, so I'm guessing you clicked on this video because 1, you were curious, or 2, you want to know how to make a bomb. I have to. Hold on, I'm getting something. Let me read this while I'm getting something. So this is just, this right here is just uranium. Like you search up uranium and this is what pops up immediately. Other than this. After the uranium ore is extracted from an open pit or underground mine, it is refined into uranium concentrate. At a uranium mill, the ore is crushed, pulverized, and beaten. Sitting and smiling. No. Sitting at the let's put that in 1 hour. Do you think? Okay. After the uranium ore is extracted from an open pit or underground mine, it is refined into uranium concentrate. That is basically a powder, kind of. It is crushed, pulverized into a fine powder. Chemicals are added to the fine powder, which causes a reaction that separates the uranium from other, minerals, because that would be bad. You don't want some stone or anything in your uranium. Sorry, I have to check over here for the Okay. It can be used as fuel, nuclear power plants, or nuclear reactions that run naval ships. It can also be used for nuclear weapons. Quote there. Uranium is a heavy. This is more just uranium stuff and about uranium. Uranium is a heavy metal which has been used as an abundant source of concentrate energy for over 60 years. Uranium occurs in most rocks in concentrates of 2 to 4 parts per million, and it is as common in the Earth's crust as tin, tungsten, and molybdenum. Uranium occurs in seawater, which can be recovered from the oceans. Uranium was discovered in 1789 by Martin Klaproth, a German chemist, in a mineral called pitchblende. It was named after the planet Uranus. This is just like fun facts. Other than this, uranium has a melting point of 1,132 C. The chemical symbol is U, yeah. Uranium atom, I guess this is kind of, yeah. Anyways, it can be split, yielding a lot of energy, therefore, well, that's where uranium is. We don't care about that right now. It is, at the bottom there, you can see the little thing. That's where it is. Here are the health effects to long time, or little time, or just being near uranium. You hear just uranium by itself, just uranium. Inhale it. If you inhale it, that'll be bad. If you touch it, that'll be bad. If you eat it, that'll be bad. Just don't in general. Make sure you're wearing a hazmat suit with a gas mask and gloves. Make sure, for the love of God, those gloves are not made of cloth. Make sure it's plastic. And make sure you're wearing a full hazmat suit, not just, you know, some average clothes. And make sure you're wearing a full head body mask that goes all around your entire head. This is the explosions of uranium. Oh no, I lost my spot. And the simple, like, this is the very simple instructions. The A and B. The detonator would explode that, which hits the uranium very hard and causes a boom, seen here. Detonators here all boom, and it all goes into the uranium, right? And this is just the simple, this is simplified, and it goes boom, seen here. Here are all the parts and where to put said parts. These are two different like you know, areas, things. Now the assembly, as it says up here, the combustion of uranium is relatively, oh yeah, this is more uranium stuff. You can read it if you want. Early nuclear research achieving the monumental goal of splitting the nucleus of an atom, known as nuclear fission. The fission is very important, same as fusion. Came through the development of scientific discoveries that stretch over several centuries, beginning in 1789, when German scientist Martin Klaparth discovered the dense metallic element he called uranium. Exploring atomic energy radiation came to a fascinating scientific mind as Marie Curie was conducting her groundbreaking research on uranium. Late 19th century, she found out the element was naturally radioactive. Curie created the term radioactive to describe the emission of electromagnetic particles from distinguishing atoms. Curie's discovery of radioactivity in elements forever changes the nature of atomic science. Building from this research, British physicist Ernest Rutherford in 1911 formulated a model of the atom, in which low mass electrons orbited a charged nucleus that contained a bulk of the atomic mass. At the center of every atom is a nucleus. Breaking the nucleus apart or combining two nuclei together, nucleuses, can release a large amount of energy. A boom, per se, a big boom. Nuclear weapons use that energy to create an explosion. Modern nuclear weapons work by combining chemicals, explosives, nuclear fission, nuclear fusion, and nuclear fusion. The explosives compress the nuclear material, causing fission. The fission releases the massive amounts of energy in the form of X-rays, which create a high temperature and pressure needed to ignite the fusion, which creates a boom. All matter that is comprised of atoms, incredibly small structures that house different combinations of three particles known as protons, neutrons, and electrons. At the center of each atom is a nucleus, plural. The plural, which is nuclei, where neutrons and protons are bound in close proximity to each other. In close proximity together. Most nuclei are relatively stable, meaning the makeup of their neutrons and protons are comparatively static and unchanging. During fission, nuclei of certain heavy atoms are split into smaller, lighter nuclei, releasing excess energy from the process. This sometimes can occur spontaneously, but it can also contain nuclei be induced from outside. Nuclei. Okay. Fusion works in reverse. When exposed to extremely high temperatures, like radiation. No, not radiation. I mean, when that proton and neutron or the nuclei is destroyed, some lightweight nuclei can fuse together to form a heavier nuclei, releasing energy in the process. Because to fuse together, they need a high amount of energy, and they have too much energy, so they have to take some of the energy away to fuse together. I'm pretty sure, I might be correct, but I might be stupid. In modern nuclear weapons, both fission and fusion in a single warhead can release some explosion energy in a fraction of a second. Then all the weapons used during World War II combined, including the Fat Man, Little Boy, the 2 atom bombs dropped on Japan. All nuclear weapons use fission to generate an explosion. Little Boy, the first nuclear weapon ever used during wartime, worked by shooting a hollow uranium-235 cylinder at a target plug of the same material. Only certain isotopes have something like that. Okay, this is important. Okay, only certain isotopes, we haven't talked about isotopes yet, of certain elements can undergo fission. An isotope is a variation of the same element with different numbers of neutrons in the nucleus. Plutonium-239 and uranium-235 235 are the most common isotopes used in nuclear weapons. Each piece by itself are not enough to constitute a critical mass, the minimum amount of nuclear material needed to maintain a fission. But by colliding the pieces, critical mass was reached, and the fission chain reaction occurred. Modern nuclear weapons work slightly different. Critical mass depends on the density of the material. As the density increases, the material mass increases. Instead of colliding to subcritical pieces of the nuclear fuel in modern weapons detonate, chemical explosions around the subcritical sphere or pit of uranium-235 or plutonium-239. Fun fact, let me stop right here. I already used it, but I used to have some plutonium-239 in my room. It's very cool. It is in fact, they are right, it is a powder. Does not mix well with like, like lighter fluid. Doesn't mix well, no. Anyways, where were I? Oh yeah, metal. The force from the blast can be directed inwards, compressing the pit and bringing its atoms closer together. Once dense enough to reach the critical mass, neutrons are injected, initiating a fission chain reaction, and producing an atomic explosion. In fusion weapons, also called thermonuclear or hydrogen weapons, the energy from the initial fission explosion used to fuse a hydrogen isotopes together. The energy is released by the weapon, creates a fireball that reaches several tons of million degrees temperature, in the same range as the center of the sun, which also runs on fusion. Maybe I didn't know I added me to this. Oh. The center of me. Oh, you shouldn't have me. Now, here's a quote from Mr. Oppenheimer himself, the famous movie. Now I've become death, destroyer of worlds, and you are now too. We aren't done. We have a few more things to talk about. One of them is pipe bombs. You know the pipe bombs. There's a pipe bomb in your mailbox. I'm not gonna read all this because I can hardly see it, but that's how to make it. Let me move out the way real quick. There you go. Oh yeah, for official use only. And here is a nail bomb. We didn't talk about nail bombs because I couldn't find any pictures about it. Like, I didn't find any pictures other than of nail bombs. Like, yeah, you can search up how to make a nuclear weapon. You can search up how to make a pipe bomb. You have to look though. And when I was looking, I didn't find anything on nail bombs other than just pictures of nail bombs. So this is the only bit of text on nail bombs that we have. And it was ripped straight from Wikipedia. A nail bomb is an anti-personnel explosive device containing nails. To increase its effectiveness at harming victims, the nails act as shrapnel. Like in grenades, there's little pellets, right, that shoot out, kind of like bullets. And that's what makes the grenade really powerful. Leading almost certainly to injury inhabited areas, such then the explosives alone. A nail bomb can also be used as a type of fletched weapons, such as weapons use of bishop's shrapnel, steel balls, nail heads, screws, needles, broken razors, darts, and other small metal objects to create a larger radius of destruction. Nail bombs are also often used by funny guys, including funny bombers, and they cause a large number of casualties when detonated in crowded places. Nail bombs can be detected by electromagnetic sensors and standard metal detectors. So watch out, all you funny men. And now, finally, for the guy who really inspired me to create this whole thing. Like, if he asked me, hey, create a Google slide for me, you know, when he was looking at Google Slides, this is what I would have sent him. And feel free to send him this. If you wanna send him something and you don't have something, feel free. This man right here, he's the one who inspired me. I'm sorry. I got a bit out of character there. By the way, let me show you, actually. Here are some nails, most commonly used. Here are two types of nail bombs. Now, let me tell you something. Nail bombs usually work best when the nails are rusty, because that causes tetanus, and tetanus is very good if you're trying to cause harm to someone. Oh hey, a nail bomb. And nail bombs can also be used as pipe bombs. As you can see here, you have a few nails sticking out. I saw a really nice one. Yeah, this one. If the nails are sharp, it would work better, and they're not rusty. But this is pretty good. This is pretty good. And here's another one. And here is a good thing to use. Now, using nails is a simple thing. What you want to really do is you want to, I don't know if you can really find a way to make these little things rusty, because they're supposed to be rusted. But you want these little guys in your nail bomb. These are called nail bombs, but you want them in your nail bomb. Like, come on. You don't want to be this funny little guy. Look at this little man. Look at this little guy. You don't want to be him. Now, what I haven't told you is I have this USB right here, right? This is called a digital bomb. So with these USBs, right, I'll just tell you here, digital USBs, right, or I forgot what else you'd call it, but these are used to destroy computers and laptops alike. Most commonly used by putting millions of files. So it's called a zip bomb. This isn't a zip bomb. This is full of many viruses. Anyways, that is going to be it for today's video. Have a great day.